I'm going to talk to you about debug performance. So it matters, and why? Well, if you try to debug code that has been compiled with optimization enabled, you should know it's kind of a nightmare. You're going to lose the control flow, you might lose information on the local variables and the call stack, and many functions will be in line. So it's not really easy to debug this sort of code. And we also know that performance matters in many fields. For example, simulations, game dev, virtual reality, VFX. We want these things to be fast. And people working in those fields want to debug their builds but still retain performance. If you have a debug build of a virtual reality game that runs at 5 frames per second, it's completely unusable. So that's not something realistic. And yeah, zero-cost abstractions are a lie, or rather a misnomer. They are zero-cost abstractions when you optimize your code. They rely on compiler optimizations, and you cannot always do that. And this leads to people actually avoiding abstractions and writing C-like code in order to have efficient debug builds, which leads to unabstracted code, which is more prone to bug, and then that leads to more debugging. It's just an annoying problem. So I think that abstractions are important, and I would really like to encourage all C++ developers, no matter in which field, to use abstractions. The code is simpler, easier to understand, and less bug prone. But the truth is that I cannot, because these zero-cost abstractions have costs. And we're going to talk about debug runtime performance, but also compilation time is something else that matters a lot. Here's an example I want to show you. It's using std_byte. It's a very simple function. I just have a byte with 1, 2, 3 initialization, and then do some bit shift, and then I return the byte. I'm going to pop over to Godbolt, and I'm going to show you that with std_byte, this is the assembly that you get generated. It's not very nice. And if you simply change that byte, std_byte to char, then you'll see that you get a massive reduction in assembly. So you're paying the price for using an abstraction in terms of debug performance. And if you imagine this in a hot loop, it's going to be very hard to convince people that std_byte is a good abstraction. So people actually might ridicule things like this when they are posted on Twitter and places like that. OK, I'm also going to tell you that when you move an int, it might be slow. So let's assume I have this function, accumulate range. It just takes 2 pointers, begin and end, and just calls to the accumulate. I'm going to tell you that when you compile this code with no optimizations, it will run 1.4 times slower in C++20 compared to C++17, using GCC and Clang from a few months ago or MSVC in the current version. Does anybody have any idea why this is the case? Yes? OK, because std_move, yes. Basically, in C++20, they optimized accumulate. And as you can see here on this slide, they added a std_move on the initializer values, on the accumulator, every iteration in order to basically avoid an unnecessary copy with types where that matters. So that's the if-def that you see there. And the std_move is actually great when you are compiling with optimizations because it's going to prevent unnecessary copies. But when you're actually running this code without optimizations, this is going to add runtime overhead. And you might be thinking, how is something like move actually adding runtime overhead? It's just basically a cast. But the truth is that while it is semantically a cast, to the compiler, it is just another function call. So you will actually see compilers emitting call instructions to std_move, which is something completely useless. So it will be a zero-cost abstraction if you don't have any overhead, which implies that you need inlining, which doesn't happen in O0. And the same issue applies to many other functions, forward, as const, as underlying. All these things should be free, but they are not. They are still function calls. And what can we do? We have something called OG in GCC. It's a flag that allows you to optimize a little bit for debuggability, but sometimes it's too much. Clang doesn't have it. It actually has it, but it's the same as O1 and has been like that for years. And MSVC doesn't have any equivalent. Some people resort to macros. Yes, this is a reasonable suggestion. You can kind of like define a move and forward macros that do the right thing without runtime overhead. And some people tried writing some papers to address this issue, but they were not accepted for various reasons. So what has been done? This is important. We had progress. GCC and Clang recently started eliding some of these function calls in the front end. So now when you write std_move, forward, and all this stuff here, in O0, the compiler will treat them as built-ins, and they will basically not generate any call instruction. This is great, and I like to see more of that. MSVC hasn't delivered yet. Not surprising, sorry. But we also have many other functions and types that are a source of overhead. For example, std_byte, even iterators. I don't want my dereference operator on a std vector iterator to actually be a function call. So how do we solve this? Call to action, I have some links here. I don't have any time anymore, but think about this. And one important thing is that the reputation of C++ in this field is at risk because we actually want people to use abstractions and not ridicule us. Thank you.